This is the MPC-1, and in this video we're going to take an in-depth look at connecting MIDI devices to the MPC. With the release of firmware 2.8, many advanced MIDI features were added, allowing users numerous ways to control external gear as well as engage with the MPC. By the end of this video, you should have a good understanding about what MIDI is, how to connect a variety of MIDI devices, and how to configure them within the MPC. So let's get started from the very top. There are some things we should know about MIDI. It is a means of communicating between musical devices. Communication typically occurs over the MIDI 5-pin DIN connector, but recently USB MIDI is becoming commonly found on devices. And it's important to know that standard MIDI DIN connectors transmit data only one way, to and from the device, depending on the ports it's connected to, either as an input or an output. Not to confuse matters, but some devices have through ports as well, which we'll discuss later. USB MIDI, on the other hand, is capable of being bidirectional depending on the device. MIDI can even be transmitted over Bluetooth or Wi-Fi on select devices. MIDI data is typically transmitted over 16 channels to send and receive data. The benefit of this is that you can have 16 devices, each configured to different MIDI channels, and each could be controlled independently. MIDI data can be several things, including note events, velocity, vibrato, note messages, stereo panning, and clock information. Having a good understanding about what MIDI is and how it's used to communicate is important, and it's the basis of all the information that is to follow. With that understanding, let's get back to the MPC. Our MPC will act as the central hub connecting all of the devices, and MIDI data will either be coming to it or from it. Let's start by discussing common devices that would transmit data into the MPC. MIDI keyboards are probably the most common device you would use to send MIDI data into the MPC. Connecting a MIDI keyboard allows you to have keyboard keys in addition to pads. MIDI keyboards come in two types of connectors, USB and MIDI DIN. USB is more commonly found, but some keyboards have both. One advantage of USB MIDI keyboards is that they are typically bus-powered, meaning that the USB connection will power the keyboard. And it's important to note that connecting via MIDI DIN will often require a separate power supply to power the keyboard. So let's connect our MIDI keyboard over USB. Connect a USB cable between the MIDI keyboard and the USB-A port on the MPC. The keyboard should power up and transmit data to the MPC. On our MPC, at the top of the touchscreen, you should see feedback indicators for MIDI in and out. If we play some notes on the keyboard, we should see corresponding feedback on the MIDI in. This tells us that at the top, at the device level, MIDI is coming into the MPC. If we tap the MIDI feedback area, we get a MIDI monitor overlay. This shows us a list of all MIDI activity in and out of the MPC. Let's show you another useful screen. If we go to Preferences and then MIDI Sync, we get the MIDI multi-mode menu. Here we see all connected devices in terms of their input and output with the MPC. And we can see our MIDI keyboard is connected as an input, which is expected because USB devices are said to be discoverable and should auto-populate on this screen. If we go to Main Mode and look at the track section of the touchscreen, we should see some feedback on our MIDI notes at the track level. But we still won't hear sound until we load a program into this track. Let's quickly browse for a plugin sound, load it, and then select it from this track's program. Now when we play our keys, we should hear sound coming out of the MPC. Next, we can record the notes we play into this MIDI track. This process is essentially the same as recording and playing the pads of the MPC. We press record to start the recording, and the metronome will count us in. Now, when we play the keys of our keyboard, those notes are recorded into our MIDI track, including velocity and other information. Note, not all MIDI keyboards can transmit velocity and aftertouch data. Now, what if we wanted to connect a second MIDI controller? For example, we could play a bass line on one keyboard and a melody on another. First, we'll need to connect our second keyboard. This may present a dilemma if we only have one USB-A port. If you have only one USB-A port on your device, like on the MPC-1, or even if you have two, like the MPC Live and X, investing in a USB hub will allow you to greatly expand your setup. A powered hub is recommended because it can provide power to connected devices without taxing the power on the host device, in this case, the MPC. Let's connect this RSH Tech powered hub to the USB-A port on the MPC. Then let's connect our MIDI keyboards to the hub. We can see that both keyboards are now powered and they are both sending MIDI to the current track. But we want to route each one to a different track as to not cause interference. We'll need to route the inputs of our MIDI keyboards at the track level. There are a few ways we could do this. We can go to main mode, open the channel strip, and then set the input of our first keyboard in the input section. We could then do the same on the next MIDI track. However, there is a more convenient way to configure the inputs. If we select the channel mixer on the left side of the touchscreen, we see an overview of the tracks within the project, and we can assign the inputs of each MIDI track on this screen. Next, we'll need to arm each track. By default, only the currently active track is armed. If we hold Shift and then press the arm button on another track, we can arm multiple tracks. Now, when we play our keyboards, each one will correspond to a different track and we can play them simultaneously. Let's take a quick moment to show you another useful routing feature. If we wanted, we could route MIDI from one track to another. For example, we could layer multiple synth tracks, but play them with one MIDI keyboard. We have set up two MIDI tracks, each with a different plugin. We can select one to be the primary, so it's controlled by our MIDI controller, and it sends MIDI to our secondary track. On the primary MIDI track, open the channel strip and select Track View. We can see several settings for inputs and a Send To section. For the input, we'll select our MIDI keyboard. In the Send To section, we'll select the secondary track. If we play our keyboard, we should hear both tracks layered together. Question: what if we don't have a USB hub but wanted to connect multiple keyboards? Well, we still have some options depending on what devices we're trying to connect. For example, this Arturia keystep has both USB and MIDI DIN. We could utilize the MIDI DIN input on the MPC to connect the Arturia while connecting this M-Audio MIDI keyboard via USB. In the MIDI track input sections, the MIDI DIN input is simply labeled MPC. We can then set that input to a track and we can play two different tracks as we could before. Note: the MPC Live and X have multiple MIDI ports, and a numbered list of ports should be available as both inputs and outputs on those devices. Question: what if we don't have a second MIDI keyboard? Could we still control multiple tracks? Well, some keyboards allow you to split the range of keys into sections that output as separate MIDI channels. If you have one of those, you could configure the keyboard with a split and assign each one to a different track, similar to using two different keyboards. Another question: if we didn't have a keyboard that allowed us to split the keys, and we didn't need to play the keyboard parts simultaneously, could we then configure one MIDI keyboard to play different tracks? With a keyboard that allows you to select which MIDI channel it transmits out, you could then switch channels to control multiple tracks. To do this, let's go to the channel mixer screen and set both of these tracks' inputs to MPC, which is where our Arturia keyboard is connected. Let's put one track on channel 1 and the other on channel 2. On the keyboard, we can play some notes on one track, then quickly change MIDI channels and play notes on the second track. Alright, before we move on from MIDI input, we have one more thing to discuss. In addition to using keyboards to input notes and aid performances, you could also use an external device to adjust parameters on the MPC. Sometimes MIDI keyboards have a section of knobs or faders that can be assigned to parameters. Additionally, there are dedicated controllers, like this MIDI Twister and this Nano Control 2, designed specifically for controlling parameters remotely. The benefit of using these controllers is that they give you quick access to several items within the MPC simultaneously. For example, we can assign volume, mute, solo, and pan from multiple programs to this controller for quick and convenient access. This is particularly helpful if you want to use your MPC in a live performance. To assign parameters to an external controller, you can use the MIDI Learn feature within the MPC. Once your controller is connected, the first step is to enable it for control within the MPC. To do this, go to Preferences, then MIDI Sync. On the input list, find the controller and enable control on the right. Now let's assign MIDI parameters using MIDI Learn. Go to the menu, select MIDI Control, and then select the MIDI Learn tab. Let's assign our program's volume to this volume slider. Press the plus button on the top left to add an assignment. Move the fader on the controller. The MPC should show the MIDI data from the controller. In the source field, select a program, and then in the target field, select volume. Our parameter is now assigned. We can quickly repeat this process for the program's pan and assign it to the pan knob on the controller. Now let's show you how to assign the mute and solo buttons, which are slightly different. Press plus to add an assignment. Then press the mute button on the controller. For the source, select our program, and then the target to be mute. Select the type field and change it to toggle button. We could make it a momentary if we want, but typically this is a toggle type button. Now let's repeat this process for the solo button. Now let's quickly test the controller by going to main mode and opening the channel strip just for visual feedback. We should see the actions of our controller reflected on the screen. Now let's move on to outputting MIDI from the MPC. In many scenarios, we want to use the MPC's sequencer and pads to control external synths. So let's explore how that's done. Most synthesizers have a MIDI input to allow for control from an external device like the MPC. This is beneficial because we can program a sequence, edit the notes, and make it repeat exactly the same every time. As we mentioned previously, MIDI can communicate over USB and MIDI DIN. Some synths have both, and some have one or the other. Here we have a Korg NTS1 synthesizer, which happens to have both MIDI in and USB MIDI. Let's show you how to connect each type, starting with USB. We can connect a USB cable directly to the USB port on the MPC or via our powered hub. Then connect the other end to the synth. This synth is bus powered and we should see it power on. Next, we'll connect our audio output from the synth into the input on the MPC. We're using a stereo 1/8" to 2 mono 1/4" cable to make this connection. Next, we'll need to configure some settings within the MPC. We have a track and we'll set that to a MIDI type by selecting the MIDI icon. Next, in the Programs section, select the MIDI port field and then select the NTS1. To complete the configuration, we'll need to set up an audio track to accept the audio from the synth. Go to an audio track and tap Input Config. Make sure the track is armed and set input monitoring to in. If we return to our MIDI track and play the pads on the MPC, we should hear corresponding audio. We can now record notes into the track. If we then play the sequence, which will loop by default, we can make adjustments on the synth until we like how it sounds. Lastly, if we wanted, we could record this audio into our audio track, which would allow us to disconnect the synth and use it for other tracks. Since the NTS1 also has MIDI in, let's quickly show you how to connect it via MIDI DIN. For this, we'll need a special 1/8" TRS to MIDI DIN adapter. It's important to note that these adapters come in different types and they're not interchangeable, so make sure you get the one that works specifically for the device you're using, in this case, the Korg. Alright, we'll connect our MIDI cable from the MPC's MIDI output to the synth's MIDI in. Since the NTS1 is also bus powered, we'll also connect USB strictly for power. A typical phone USB power supply should work for this purpose. Connect a USB-A to USB micro B cable from the power supply to the synth. It should power on. The audio connection is the same as before. Connect the audio output from the synth to the audio input on the MPC. The MIDI DIN settings within the MPC are similar to the USB settings, although the device name will be different. In the Program section of our MIDI track, in the MIDI port field, select MPC for the MIDI DIN output. We should now be configured and we can create some magic. Now, what if our synth were multitimbral and we wanted to control each synth voice independently? For example, we have the digitone here, and if we wanted to, we can control each of its 4 synth tracks independently. First, we'll connect the MIDI output from the MPC into the input on the digitone. For audio, we'll use 2 1/4" cables going from the digitone's audio outputs into the MPC's audio inputs. This means audio from our 4 synth tracks will be combined into one stereo track on the MPC-1. Note, on the MPC-X, you could use 2 stereo inputs and have 2 stereo audio tracks. Within the MPC, we have 4 MIDI tracks to correspond to the 4 synth tracks on the Digitone. Each track's MIDI port should be set to MPC, as that's the MIDI DIN output. Now, the trick is to set each track to a different MIDI channel, and both the MPC and the Digitone need to have these exact settings. For example, we could set our first MIDI track to MIDI channel 1, 2 to 2, 3 to 3, and 4 to 4. We'll need to do the same on the Digitone. We'll go into the MIDI configuration menu and set each synth track to input on the same MIDI channels as the MPC. When we switch between the tracks on the MPC and play the pads, we should hear audio from each synth track coming back into the MPC. From here, we can program notes into each MIDI track, record audio into our audio track, or even sample each synth into dedicated audio tracks. The next level of complexity to explore would be to add another synth into this setup. Let's add the Zoya, which communicates over MIDI DIN via an 1/8" adapter. We've already used the MIDI output on the MPC-1, but one of the benefits to MIDI DIN is the ability to daisy chain devices. Our Digitone has both a MIDI DIN output and a MIDI through port. We'll want to connect to the MIDI through port, which allows our MIDI signal to pass through the Digitone and onto the next device in the chain. Alternatively, we can use a MIDI through box if the devices in our setup don't have a MIDI through port. Connect a MIDI DIN cable from the MIDI through port of the Digitone to the MIDI input on the Zoya. Next, let's discuss audio routing for a moment. We could route audio from the Zoya into the audio input on the Digitone. The Digitone has an internal mixer which can combine audio with its internal synths and then send it to its output. This will allow us to have 5 independent synths to control from the MPC, and all of the audio would come back simultaneously into the MPC's audio input. Alternatively, we could route audio from the Digitone into the Zoya and then to the MPC. The benefit of this is that the Zoya is not only a synth, but also a powerful effects processor, depending on which preset is loaded into it. If we want to use it for effects, we'll want it downstream from our Digitone. If we want to use it as a synth, we'll want it upstream from our Digitone. But for this example, let's just stick to creating a 5-synth chain and route audio from the Zoya to the Digitone and to the MPC. Once we've made our connections, we need to configure the MPC. We still have 4 MIDI tracks assigned to 4 MIDI channels on the Digitone. We'll add a 5th MIDI channel for the Zoya. Its port should also be set to MPC, but we'll set its channel to 5. On the Zoya, we assign our synth presets MIDI module channel input also to channel 5. This means MIDI note data is received at the preset level, not the device level. If all goes according to plan, we should have 5 synths to control from the MPC. Now, this is a good time to point out that you can send program messages from the MPC to synths that can accept them. The benefit of this is that we can switch sound presets from another device and record those changes into a sequence. For example, on the MPC, in the Zoya's program section, we could change the program number and it will change the preset on the Zoya. Question: how will this be different if we connect everything via USB instead of MIDI DIN? Well, there are some similarities and differences, so it's best we explain it. Say we want to control MIDI DIN devices like the Digitone and the Zoya, but we need to do so over a USB port. We can use a MIDI to USB interface like this MIDI Plus T-Box. This model has 2 inputs and 2 outputs. Now, each of our synths could be connected via a dedicated MIDI output port without daisy chaining them together. The USB from the interface box could go directly to the USB-A port or to the hub. The settings within the MPC are similar. But let's take an extra moment to quickly configure our interface box. If we go to the MIDI multi-mode menu within Preferences, we see that both sets of inputs and outputs appear on this list. USB devices are discoverable, so their names auto-populate, but it would be helpful to rename the output ports according to the device they're connected to. Let's rename output 1 on the T-Box to Digitone, and rename output 2 to Zoya. Alright, jumping to our MIDI track pages, we need to set the MIDI ports of our 4 Digitone tracks to the Digitone, and our 5th track will be set to the Zoya. The MIDI channels should remain as they were previously, 1 through 4 on the Digitone and 5 for the Zoya. When we test each track, we should get an audio signal coming back into the MPC. We could continue to build off this setup if we wanted to. We could add a MIDI keyboard. We could add a USB hub and start adding USB devices. We could add a controller to control various parameters as well. You get the point. The one thing to note when the complexity of your system begins to grow is that audio routing should be well considered. Having a dedicated audio mixer is the recommended means of routing audio from external devices. Otherwise, you'll need to get creative about daisy-chaining audio between devices. Since some devices don't have an audio input, this is where you'll run into limitations within your setup. Alright, some of you may be wondering about Bluetooth and Wi-Fi connectivity. Our understanding is that the MPC Live and X both have the ability to send and receive MIDI over Bluetooth and Wi-Fi. Since the MPC-1 does not have Bluetooth or Wi-Fi, we won't be able to demonstrate these features. But that may be a topic for another video. We may be at the end of this video, but hopefully this is only the beginning of your exploration with MIDI and the MPC. So get creative, experiment, and have fun. If you made it this far, you're awesome. Give yourself a high five, and give a like if you learned something and enjoyed this video. And subscribe for more content like this. Your support helps us grow this channel, and it is always appreciated. Everybody counts. Thanks.